Hi, my name is Poojan and I am going to represent Team 21 CSCI 572, that is USC's Information Retrieval and Web Search Engines project on representation of polar data using D3, banana, and facet view. So today I'm going to show how we visualize some of the challenge questions using D3. First of all, we tried to figure out what time-based trends exist for the discussion of oil, iron, and other natural resources in the Arctic region. So we crawled the data using polar websites, then we indexed it using solar, and now we are on the final stage of visualizing it. Here, as you can see on the map, we have some pinpoints such as Anchorage or Aniak, which show the location and latitude of the articles or the content that were found while indexing this document. So these locations are of highly importance when you think about oil or iron natural resources in the Arctic region. Next, D3 widget is basically based on the TF-IDF for the term frequency found in the content of this articles. So say we looked up human sea ice relationship document and we found that the photographed mountain moisture are particularly important and are highly relevant to the data. Next D3 element we are going to see is the cosine relationship with the URL. We compared cosine relationship with all the URLs and found which URL is most efficient and most highly relevant. Next, in terms of trends, we also looked at the content and found that this particular words have higher frequency and are highly relevant. Say climate, Arctic, and description or transportation are more important when you think about oil or iron resource trends. We also have a bubble menu, which allows a user to look at any particular document and then see what other directions does the document lead to. Say this particular document goes about looking into extraction, knowledge, and quality of this exploration. Finally, we were able to collocate all the documents in this query and then able to find out the locations using Clavin. So then we were able to map it using a pie chart, and as you can see, a large number of exploration is done in the Arctic region with a minute amount of exploration done in Northern Europe or Alaska or Canada, and so on and so forth. Next query we're going to look at is what kind of regions are of particular interest when you think about Arctic or Antarctic. So as you can see, there is a geocenter and there is a more like focus on the Arctic region when you think about David Strait or Ellesmere Island. Similarly, you can see through other D3 elements how we are able to find more relevant data and more relevant info of, say, for example, research or Aeon Cadiz or basins is more important when you think about the regions in polar data. Similarly, same with the location. Next, we were able to predict what kind of regions are of national security interest. So say Alaska or Boulder or Russia are more important in terms of maritime, air, and sea when you think about the polar data, or say South Pole. We were able to represent the same data using other D3 elements. So as you can see here now that the snow, Antarctic, or like role or war seems more important when you think about national security interest. Same here, as you can see now the entire geographical distribution has changed. Alaska and Gulf of Sea of Ireland seems more important as a national security interest, or probably Arctic National Wildlife Refuge is more important when you think about the resources and the sea and land and security interests. Next, we were able to represent the science data and measurements related to climate change in association with the aquatic animals. So we found this content and we were able to map the documents and location on the map using Clavin. We did all the similar processing and we were able to find that buoys or human dimension played a major impact role, or the iceberg melting played an a huge role in the climate change and its effect on aquatic animals. Similarly, carbon also played a major role in this effect. We were also able to see the bubbles or whether external resources lead from a particular document, say biological, European, and initialization or human dimensions are more frontiers of the resources going forward. And then lastly, we were able to do the similar distribution with locations using pie chart. So we were able to see how Alaska and National Wildlife Refuge seem to be important places when you think about the polar data and the content originating from articles. Next, we were able to see a dashboard based on Banana. Banana allows us to see a non-timed or timeline series. So we have two series. One is non-timed series. So here I've opened the non-timed series and now I'm going to search oil and let's see how many hits we are getting. So here it shows 73 hits. Now let's select some of them, title and ID, and as we can see the MIME types change based on what we selected. So now we have more PDFs and more kinds of other MIME documents collected when you search about oil. Similarly, we can show a time trend that 2014 it was like 18% and as compared to 2012. We also allow users to see a tag cloud of all the relevant words found in the title and the content. Here we show a heat map of comparing the MIME type with the document found with respect to this query. And finally, you are able to limit your search using query. So these are the relevant documents or these are the relevant words when you think about oil. So now say blank ad and the query will get updated related to oil industry, benthic econology data, and so on and so forth. Next, I'm going to load a time series. Time series allows us to look at the data with comparison to time. So now I have a time video from 1950 to 2015 and I'm going to search polar bear. It gives me 108 hits with a histogram of showing what documents were recorded during what time. As you can see, these are all the documents that occur between this time range. Now suppose I want to filter further using say title and author. So here you can see these are the documents that give specifically are annotated with the title and author keywords. Next, we are going to look at the facet view. Facet view allows anyone to search using several facets. So here I am going to search oil. This gives me a number of specific documents with titles as extracted. Suppose now I want to look at this particular PDF which has some data about oil. So here I am with the document and I can look through it and find using an easy facet view. Next, I can also search polar bear and notice how the search automatically updates with respect to the documents. Not only can I search the title, but I can also search the content inside it. So this is a text document and it's polar bear adipose analysis. So it looks to the description, metadata, and finds the most relevant documents provided by this query. So in this way, we are able to identify several and represent and several challenges and search that scientists or other users can use with respect to polar data. Thanks a lot once again for watching our project. It was Team 21 for USC's CSCI 572 course. Thank you.